The James Webb Space Telescope has essentially sent Earth a gigantic exhortation, and it's moving closer. This forewarning comes from the exoplanet Proxima b. With each new picture sent back, extra questions arise, leaving experts terrified. Every portrayal from this distant planet makes us marvel more about the mysteries of the universe, creating requests about a potentially threatening planet near Earth. Could there be a connecting pariah planet that has hostile objectives? Could Proxima at any time address a threat to our very presence? The subject of untouchable life has intrigued humanity for many years. Anyway, with present-day developments like the James Webb Space Telescope, it has turned into a question we can investigate more thoroughly than any time in recent memory. Yet, the universe isn't simplifying it to find answers. We continue to use our best gadgets, for instance the James Webb Telescope, to get looks at distant planetary systems, hoping to find clues that might indicate life beyond Earth. We ought to be practical. However, every new picture and snippet of data reminds us of how little we truly know. While these discoveries could be groundbreaking, they also highlight the endlessness and complexity of the universe, leaving us with extra questions than answers. Sorting out a far-off planet like Proxima b could redefine our position in the universe. For specialists in cosmology, this is exciting, but for the general populace, it often feels like just another piece of space news. Distant, calculated, and at times overwhelming. These revelations raise unexpected issues rather than answer them, leading many to wonder how this influences life on Earth. Might Proxima one day harbor life or even intelligent life that might, one day, present a threat to us? No matter the immense power of the James Webb Space Telescope, it can unfortunately show us only so much. Sure, we've learned a few impossible things, like the truth that we now have stunning new pictures of Proxima b and that the universe is far greater than we ever imagined. Anyway, what comes next? The possible consequences of these discoveries can feel as vast as the actual universe. Proxima b, discovered in 2013, due to its gravitational association with its star, was a huge leap forward for various specialists. Finding this exoplanet was like finding another massive neighbor. Proxima b is just slightly bigger than Earth, and it orbits its star predictably, making it a fascinating subject for further investigation. From a scientific perspective, the possibility of an alternate universe so close to our own is exciting. Yet, for most people, it's hard to relate to a place that is 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever built would require several centuries to reach it. Imagine what it might be like to stand on Proxima b. Its star, Proxima Centauri, would appear as a faint red light overhead, much cooler and darker than our Sun. Proxima b orbits so quickly that a year there lasts just slightly more than 7 days. One side of the planet constantly faces the star, meaning it experiences eternal daylight, while the opposite side is shrouded in perpetual night. Seems like something out of a science fiction novel. However, reality would be far harsher on the bright side of Proxima b. Any water would likely evaporate into steam due to constant exposure to heat, while on the dark side, the water would freeze into solid ice. Proxima Centauri, the planet's star, is also not a calm and stable neighbor like our Sun. It emits dangerous flares and intense radiation, making the outer surface of Proxima be a hostile place for life. Taken together, this isn't the kind of neighborhood where humans would want to settle. The search for life beyond Earth hit a peak in late 2020 when researchers detected a mysterious signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had an unusual frequency of 982.551 MHz, which caught everyone's attention. Such a signal could, in theory, be a sign of advanced technology. It is too early to make any conclusions. More recently, the James Webb Space Telescope has fueled even more excitement by suggesting that Proxima b could have water vapor in its atmosphere. Water, as we know, is a key element for life, and its presence could be a game changer. To better understand how much water is present on Proxima b, scientists are using advanced techniques like spectroscopy. This method allows them to detect the gases surrounding the planet, acting as a cutting-edge scientific tool. By examining the planet's light spectrum, scientists can identify specific gases like oxygen, methane, and carbon dioxide, which are key for life. Atmospheric modeling is another important technique. By using computer simulations of Proxima B's climate, researchers can make rough estimates about its conditions. These models serve a similar purpose to how scientists use dinosaur fossils to speculate about what dinosaurs might have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the remarkable variety of living things on Earth. Extremophiles, for example, are tiny organisms that can survive in extreme environments, such as boiling underground springs, acidic lakes, and the freezing cold of Antarctica. These resilient creatures show that life can adapt and thrive under conditions once thought impossible. Might life on Proxima B one day be similarly adaptable? The quest for life on Proxima B presents monumental challenges, not just in terms of space travel but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere likely won't provide much protection. Moreover, the distances involved are so vast that new types of propulsion systems are needed to make space travel to Proxima be feasible. Concepts like solar sails, particle drives, and even more speculative ideas like warp drives offer exciting possibilities for future exploration. However, these advancements are still in their early stages and require extensive research before they can be used in real missions. We are still in the early stages of understanding the potential for space travel to distant planets like Proxima b, and it's important to acknowledge the immense technological and scientific hurdles we must overcome. The distances are so vast that even with the most advanced propulsion systems, we would need to think creatively and innovatively about how to traverse these enormous stretches of space. Current space missions are limited to our own solar system, with the farthest spacecraft like Voyager 1 having just left the edge of our solar system. Reaching Proxima b, at 25 light-years away, would require propulsion technology far beyond what we currently possess. Concepts like solar sails, which use the pressure from light to propel spacecraft, are promising but would require years, if not decades, of development to make such missions viable. Similarly, theories such as the potential use of antimatter or warp drives offer futuristic possibilities, but these remain speculative at best, with little to no practical application yet. This is not to say that the future is without hope. The possibility of discovering life, even microbial life, on Proxima b would not only answer profound scientific questions but could also alter the course of human history. It would confirm that Earth is not alone in the vast universe. However, whether or not we can make the leap to understanding Proxima b or even travel there remains to be seen. This is a frontier of science that will require collaboration, innovation, and time. As we continue to push the boundaries of space exploration with advanced technologies like the James Webb Space Telescope, we may one day find answers to questions we've been asking for centuries. But even then, new questions will arise. The mysteries of space are infinite, and each discovery opens up new paths for exploration and understanding. For now, we are left to ponder: what lies beyond our solar system? What secrets do distant planets like Proxima b hold? Could they harbor life? Or will they remain as enigmatic as the stars themselves, offering only glimpses of answers as we reach further into the unknown? In the end, the search for life in the universe is not just about finding other civilizations. It's about understanding our own place in the cosmos. Each step we take brings us closer to the realization that the universe is far larger, more complex, and more mysterious than we ever imagined. And perhaps, one day, Proxima b will no longer be a distant dream, but a tangible reality we can study, explore, and even visit. Until then, the journey of discovery continues, fueled by curiosity and the relentless human spirit to uncover the unknown. To remain sensible, finding life on Proxima b is loaded down with mechanical and logical difficulties. Exclusively by advancing our technology and expanding our understanding of the universe might we hope to unlock the potential of distant worlds like Proxima b. This pursuit isn't just about satisfying curiosity. It's about pushing the boundaries of human achievement. Might we one day set foot on Proxima b or even connect with life there? As we consider the long journey to Proxima Centauri, finding extraterrestrials no longer feels bound to the realm of science fiction. Instead, it appears as a genuine, tangible possibility. This fascinating shift from a distant dream to a scientific undertaking has drawn serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating vast resources to transform what would normally be an incredibly lengthy journey, one that could require several centuries using today's technology, into a mission feasible within decades. The goal of reaching another star system within a human lifetime has ignited innovation and optimism in the academic community. However, these grand aspirations are immediately tempered by the stark realities of our current technological limitations. Despite remarkable advancements in space exploration, traveling to Proxima Centauri, even at 4.2 light-years away, still presents overwhelming challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey plausible within any reasonable time frame. Breakthrough Starshot, one of the most ambitious projects, envisions using powerful laser-driven sails to propel small spacecraft to speeds of up to 20% the speed of light. While this concept shows promise, it remains in the experimental phase and requires overcoming numerous technological and logistical obstacles. These include mitigating damage from space debris and ensuring reliable long-distance communication. While the dream of reaching Proxima Centauri and potentially discovering alien life is closer to reality than ever, it remains grounded by the limitations of current technology. Accelerating a spacecraft to approach the speed of light with today's tools feels almost impossible, like trying to solve a difficult puzzle in the dark. Even ambitious projects like Starshot, which aim to propel a craft toward Alpha Centauri using lasers, face immense practical challenges. For example, Earth's atmosphere causes disturbances for the lasers, making it difficult for space exploration instruments to operate with the precision required. One proposed solution is the use of adaptive optics, smaller lasers on satellites that continuously monitor and adjust to atmospheric disturbances. This system would help powerful ground-based lasers remain focused on spacecraft as they travel through space. However, the laser propulsion method demands a colossal amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a short duration. Imagine setting up 100 million lasers over a vast area just to push a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still require 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. Yet, the challenge of reaching Alpha Centauri isn't solely about overcoming technical hurdles. Natural barriers also pose critical risks. The sun's gravity, the presence of space debris, and the sheer enormity of the distance all present significant challenges. Even communicating with a spacecraft en route to Proxima b would require sending messages through time. It would take nearly 4 years for a signal to reach it from Earth. Despite these daunting challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deeply rooted love for discovery and exploration, rather than practical necessity. Even bold endeavors like Starshot, which aim to shoot a spacecraft toward Alpha Centauri using lasers, face numerous operational difficulties. Nonetheless, overcoming these issues could transform space exploration. Still, the potential risks involved, including communication delays and natural hazards, demand meticulous planning. Despite the challenges, many experts believe that the rewards far outweigh the risks. Finding life on Proxima b or another distant exoplanet continues to captivate minds around the world. Discovering life on another planet would be the most profound scientific breakthrough in humanity's history. It would not only reshape how we view ourselves and our place in the universe but could also provide insights into the origins and ultimate fate of life on Earth. While humanity dreams of a future where we can travel to the stars, we are also taking practical steps in our search for life. The discovery of planets like Proxima b is just the beginning. Telescopes like Kepler have been crucial in identifying distant worlds that could support life. By observing how these planets interact with their stars, either by blocking some of the starlight as they pass in front or by making the stars wobble due to gravitational pull, we can study their size, composition, and potential habitability. Now that Kepler's mission is complete, the James Webb Space Telescope is stepping in to take over. Its ability to detect infrared light allows it to study planets that were previously too faint or distant for us to analyze. As we study Proxima b and other exoplanets, we are expanding our understanding of the universe and, with it, the possibility of life beyond Earth. The James Webb Space Telescope has opened new doors in the search for extraterrestrial life, particularly with the discovery of exoplanets like Proxima b. While we are still in the early stages of exploring the potential for life on this distant world, the technology and curiosity that drive us will continue to push the boundaries of what we know. If Proxima b harbors life, the quest to understand it has already reshaped our perception of the universe. As we delve deeper into the mysteries of the cosmos, the search for extraterrestrial life takes on new urgency and excitement. Advances in technology, particularly in observational astronomy, have enabled us to look farther into the universe than ever before. Instruments like the James Webb Space Telescope are revolutionizing our understanding of planetary systems, allowing us to explore the atmospheres of distant worlds and uncover potential signs of life. One of the most fascinating aspects of Proxima b is its location in the habitable zone of its star, where conditions could allow for liquid water to exist. This region is often referred to as the Goldilocks zone, where temperatures are neither too hot nor too cold, creating an environment ideal for life as we know it. Experts believe that if Proxima b has the right atmospheric conditions, it could potentially support living organisms, even if they differ significantly from those on Earth. Moreover, the study of Proxima b opens a window into the conditions that may have influenced life on our own planet. By examining the geological and atmospheric characteristics of Proxima b, scientists can gain insights into planetary development and evolution across different star systems. Such comparative studies could illuminate the processes that lead to habitability, offering clues about how life might emerge in diverse environments. Astrobiology, the field devoted to the study of life in the universe, plays a crucial role in this exploration. Researchers in this discipline focus not only on finding life but also on understanding the potential for life to adapt to extreme conditions. This knowledge could enhance our search for life in places previously considered uninhabitable, such as icy moons like Europa or the methane lakes of Titan. The excitement surrounding Proxima b isn't just about the possibility of finding life. It also highlights humanity's innate desire to explore and understand our place in the universe. As we ponder the potential existence of intelligent life forms, ethical considerations come into play. If we were to encounter extraterrestrial civilizations, how would we communicate? What protocols would we establish to ensure mutual respect and understanding? Moreover, the societal implications of finding life elsewhere are profound. Such a discovery could challenge existing beliefs and philosophies, prompting a re-evaluation of humanity's role in the universe. It could inspire a new era of collaboration as nations and organizations unite in a shared quest for knowledge and exploration.